And welcome to the Pole Shift News. Before we go on, I'd like to thank those people over the last couple of weeks that have made a contribution to the research and this channel and the website that we've got now covering this topic of the magnetic pole migration. We were looking at, on the left, a temperature modelling map, and on the right, the data that was collected from Swarm a few years ago in relation to where the density is of the magnetic North Pole and South Pole, looking at those high regions of magnetic field strength, both over the northern and southern hemisphere. But the reason why I like to put these two maps together, and especially at this time of the year, is to see whether there's any progression with regards to these areas, because at first sight you'll see there's very similar patterns forming in temperature and magnetic field strength. But what I like to see is, whether they are changing. Now, we've been looking at these for the last few years on this channel, and it's not something that is accepted by mainstream climatologists and other organisations, that there is a link between temperature in regions and magnetic field strength. But I think, with you looking at this, you'll agree that there is more than a coincidence in these patterns. In particular, we should be concentrating on the left-hand side, those darker regions, or those more purpler regions over the northern and southern hemisphere, because where it is colder is where the magnetic field strength is stronger. And you can see that there is a very similar pattern on the magnetic field model on the right-hand side. You can see that the plumes, both over the northern hemisphere, there's two, and there's a little gap in between where the field strength is weaker, and this pattern is carried on the temperature map. You've got two regions, or two plumes, where it's much colder, and in the centre it's a little bit warmer, and that is because where the magnetic field strength is strongest, it is also, by no coincidence, coldest. So we can look at temperature anomalies with regards to, especially at this time of the year. In a few videos ago I said we was approaching max tilt. It's not actually the Earth that's tilting, it's just its angle with relation to its orbit around the Sun. At this time of the year, it puts the northern hemisphere in a position where it receives a lot less sunlight and therefore cools down much more. But what I'm interested in looking at this at the moment is there doesn't seem to be much change over the southern hemisphere, and usually it's much smaller than that. So, is the planet still moving in favour of a cooler climate? And is that in relation to two factors now? Is it in relation to the sunspots, which are at an all-time low at the moment, even though we are around still a solar maximum, and there should be a lot more? Or is it due to the Earth's magnetic field, or magnetosphere, weakening more, and therefore cooling the planet as a whole? It doesn't go well with what these mainstream climatologists are coming out with, that we are going into a global warming period, and that is caused by CO2. There are many arguments to be had there. Yes, it can't be a good thing if all of a sudden, over a period of time, we pump, millions of tons of CO2 into the atmosphere. I have no doubt that could have some effects. But let's look at it from a biodiversity point of view. If there's more carbon in the atmosphere, then those plants and other vegetation or species are going to thrive, because there's an abundance of something it needs. And this was true for the Earth many millions of years ago, when there was just a pure atmosphere almost of, or a majority of the atmosphere was consistent of CO2. What cleaned that CO2 out of the atmosphere was an eruption in organic plankton that scrubbed it naturally clean out of the atmosphere. And then when it became less in the atmosphere, the amounts of these species in the sea, of zooplankton and planktons of various types, died off. It was a case of, the word fails me at the moment, but basically supply and demand. If there's a little amount of food, there's going to be a little community of a particular species. But getting back to the chart, we can see that by no coincidence there is a relationship between temperature and magnetic field strengths, and it should really come as no surprise to us, because at the end of the day these magnetic poles are in the regions of the north and south of this planet where the poles are. It's also within the region of the rotational axis. And this is important because we are coming up to now 2 weeks away or less of the planet reaching its maximum angle away from the sun, and that is commonly known as the winter solstice. And we can do something to check at this time of year to see if the rotational axis is off slightly, and it is on the cards. For the fact is, if we're going to start seeing the temperatures moving around over the northern hemisphere, we're going to start seeing, we've already started to see the magnetic north pole migrating over these regions. So why should not then the only other major anomaly that takes place over these regions also change, and that be the rotational axis? I have an inkling we will see it, but I don't think we're going to see it yet. I think we will see it definitely when the magnetic migration gets into those weaker field lines, and therefore moves or migrates a lot quicker out of the northern hemisphere and goes into that reversal. Or the other thing that we could be seeing, and it's not off the cards, it really isn't, and that is a complete failed magnetic reversal. And that could be due to the fact that something has stalled in the core of this planet, and therefore it's not going to reverse. Now, we have had many reversals, and you're probably going to say to me, well then Gene, why would it stop this time? And the simple reason is for that is because this magnetic reversal that we're in right now is completely different to all the others that we've experienced or recorded, at least in history. And the reason for that is it's nearly 500,000 years overdue. It is definitely, by all means, delayed for some reason. And it's alarming. I think it's really alarming for that reason, because if we look at other planets within our solar system, such as Mars, we know that they had an atmosphere at some point, maybe also water on their surface. And also, we know they had a magnetic field, and they no longer have. And all these things are connected to each other. If the magnetosphere disappears from a planet, then that is its protective shield from harmful cosmic rays. And these cosmic rays will have a sputtering effect on the upper atmosphere, whereby it will just strip away, all of our atmosphere, leaving us exposed to, severe bombardments of these cosmic rays and particles. This problem is made much worse by a solar period of, historical lows, where we are not quite there in the historical lows, but we are definitely moving into those periods of times where we could witness another Dalton minimum or another Maunder minimum, where sunspots, go into hibernation. And over a prolonged period of time, we experience what was recorded then as the mini ice age. So it baffles me, it really does, why climatologists don't link, solar temperatures and activities with regard, sorry, not temperatures, but just activities with regards to sunspots to predictable global temperatures. Because, back then it was noted for almost a 50-year period that whilst there was a low amount of sunspots, in fact there was none recorded for many years, there was also a period of time experienced as was classified then as the mini ice age. So I'm going to round up this video here, in a nutshell, what we're looking for at this time of the year, during around the solstice, when it's furthest away the northern hemisphere from the sun. It goes on much colder over that region, and therefore brings out these magnetic trends, or these plumes, these darker purple regions. I would expect to see over the next few weeks, when we reach that maximum period where the sun doesn't rise anymore on the winter solstice, these regions to go just a little bit cooler. And even after a few weeks afterwards, because of the temperature inertia, when you starve a certain region of solar radiation for a period of time, it will, even though you start to introduce that sunlight back to that region, will gradually get colder for a little while and then reach equilibrium and then start to rebound back. But what I will be looking for over the next few weeks is these regions where it's more colder to go a little bit more than what they are at the moment. But, you know, for argument's sake, with regards to these climatologists, you know, you're well behind on this research. You know, the magnetic anomalies do have major effects on probably all the planetary mechanics, and, you know, failing to include these in your weather models is only going to, you know, reduce the reliability and accuracy of these weather models. And not only that, you can predict long term climate on this planet by incorporating them into your model. So it's a, you know, it's a major thing that they're missing out on. You can clearly see where on the southern hemisphere, where we have this great big plume over on the magnetic anomaly chart, and compare that to the temperature chart, you can see on the lower right hand region of the Antarctic down there, it is more dense in that purple region, indicating that the temperature's around -30 to -60, or probably even a little bit more. And same for the northern hemisphere, you know, probably -20 to -50 in that region. So, you know, it's something that we can keep our eye on for the next few weeks, and it just again confirms that there is a relationship between temperature and magnetic anomaly. Another thing that these climatologists, I think, could include into their long-term weather modelling systems is definitely the solar output with relation to the sunspots, because, you know, we've already recorded low sunspots equals low temperatures, you know, and for that reason, you know, it'd be a good idea if that was included in the weather modelling systems, at least over a longer period of time. And, you know, I just want to round up with the rotational axis. We can check whether the rotational axis has started to shift on this planet simply by monitoring the winter solstice, which will be in less than 2 weeks now. And we can do that by measuring at the meridian, or the middle of the day, where the sun reaches its maximum altitude in the sky. We can measure the angle of that to give us an indication of whether it is at its recorded previous altitude. If it's not, then something has changed with regards to the rotational axis. The other thing we can do is also note on that day where on a compass the sun is setting. And again, if it's setting somewhere it shouldn't be. Now, in my region, the sun sets this time of the year at around 52 degrees latitude. It sets southwest. And, you know, I've done a video where we've done it in the summer solstice, the winter solstice, and then the summer solstice again. We checked it, and it hadn't shifted. But that's not to say it won't. And the reason why I say that is because they're not in these regions for no reason at all. And the magnetic poles in these northern and southern hemispheres are not there by just coincidence. You know, the temperature in these climates and the fact that we have these Arctic regions are not there by coincidence. And if they're not there by coincidence, then certainly the rotational axis of this planet equally is not there by coincidence. And if you start to see one change, you're going to start to see the others change. Now, we have had some stories come from the Inuits and, you know, these descendants from these Eskimos in these regions that have claimed that the sun is already setting in a different region to what it should be. And from what I've gathered is they use for their navigation snowdrifts that have been there for many, many years, and they navigate by these things. Some are called snow tongues. It's just the way that the snow forms, freezes, and then more snow forms over it. But what them are in relation to is the polar jet streams, and there has been a change in the polar jet stream, so naturally it's going to shift the terrain, in this case the snow and the snow tongues and the drifts, into other regions. So if they're using those as navigation tools and they've changed, well, they're going to start to think there is something more going on. I mean, this is not uncommon for weather patterns to shift and change the terrain. If we just look at deserts, the sand dunes you know, can be at 50 feet you know, above sea level one day, and then a few months later, you know, that sand dune has has changed its location, and the prevailing winds have shifted it completely. So what I'm saying is there are methods, more accurate methods, of measuring whether we've got a rotational shift and whether the sun is setting in different regions, and we can use those, and we can use them at this period of time that we're in to check that. And it is important, because if the rotational axis starts to shift, then there's some major planetary changes taking place. I mean, there are already Don't put the magnetic pole shift off as just like some people do that are new to the topic and they don't know a lot about it. This will just be a case of looking at your compass and it'll go from north to south. There's much more going on in the core of this planet during a magnetic pole shift, even if we use the model of the dynamo that mainstream science believes understands to the best of its ability. There's much, much more taking place, and as a result of losing the magnetic field, it can cause very serious implications. Well, how serious then? Shall I just give you a worst case scenario? All biological life on this planet could cease. That should be a sobering fact to leave this video on, and that's how serious this topic is. And you must ask yourself, why mainstream media and other scientific organisations, well-known ones, no need to mention them, why aren't they on the topic of the magnetic pole shift? Where are they? It affects every one of us on this planet. It already is creating major changes in climate. So, where are these climatologists that should be on the case of the magnetic pole shift and should be saying that there is much worse effects to come? I know that there is that fact that we've never recorded a magnetic reversal, and the other major fact is that this is a rare event, and it's made even rarer by being delayed by 500,000 years, but it's still a very significant event that could have some very serious complications for this planet and its biodiversity as well. Species across the range will be affected. We're already seeing how it's affecting the marine life on this planet. It's alarming. That's why I covered the topic. I know that some of the implications that are going to be crossed by us during this magnetic reversal. I know what we're going to be facing. And, things can change. We are at that point in time where things can change quick. Alright, we're slowly leaving the region of the stronger magnetic fields of this planet, and we are entering the weaker magnetic fields. If the magnetic fields responsible for putting the jet streams where they are, which they are, guys, we don't get a polar jet stream in the polar region for no reason, and the subtropical jet streams are not there for no reason. It is because the poles sets the mechanics up of this planet to put them in them places. That's why in the most hottest region on this planet, the equatorial region, there isn't a magnetic north pole or south pole. The poles are positioned in the colder regions, and that is because in the colder regions they can be stronger in them fields. And this has a relation to what is going on within the core of this planet, which is not quite understood. So I'm going to leave it there, guys. Again, a big thanks for those people that have supported the channel over the last couple of weeks. It's what gives me the time to look into all this. It funds, the equipment that we're building, the bespoke equipment, and it affords me, the ability to do this. So, great big thanks to you. This is something that we all will go through on this planet, and it will be the case, as it always is, of the few that do something, to warn the others about and give them some knowledge of this, super massive event that is going pretty much unheard at this point in time. So I'm going to leave it there, guys. The link's down below if you want to help contribute, keep some of the stuff going on this channel, and I'll thank you for that. As always, guys, I'm going to say what I usually do. Bye for now. Hi, and welcome to the Pole Shift News. Before we go on, I'd like to thank those people over the last couple of weeks that have made a contribution to the research and this channel and the website that we've got now, covering this topic of the magnetic pole migration. We were looking at, on the left, a temperature modelling map, and on the right, the data that was collected from Swarm a few years ago in relation to where the density is of the magnetic North Pole and South Pole, looking at those high regions of magnetic field strength, both over the northern and southern hemisphere. But the reason why I like to put these two maps together, and especially at this time of the year, is to see whether there's any progression with regards to these areas, because at first sight you'll see there's very similar patterns forming in temperature and magnetic field strength. But what I like to see is, whether they are changing. Now, we've been looking at these for the last few years on this channel, and it's not something that is accepted by mainstream climatologists and other organisations, that there is a link between temperature in regions and magnetic field strength. But I think, with you looking at this, you'll agree that there is more than a coincidence in these patterns. In particular, we should be concentrating on the left-hand side, those darker regions, or those more purpler regions over the northern and southern hemisphere, because where it is colder is where the magnetic field strength is stronger. And you can see that there is a very similar pattern on the magnetic field model on the right hand side. You can see that the plumes, both over the northern hemisphere, there's two, and there's a little gap in between where the field strength is weaker, and this pattern is carried on the temperature map. You've got two regions, or two plumes, where it's much colder, and in the centre it's a little bit warmer, and that is because where the magnetic field strength is strongest, it is also, by no coincidence, coldest. So we can look at temperature anomalies with regards to, especially at this time of the year. In a few videos ago I said we was approaching max tilt. It's not actually the Earth that's tilting, it's just its angle with relation to its orbit around the Sun. At this time of the year, it puts the northern hemisphere in a position where it receives a lot less sunlight and therefore cools down much more. But what I'm interested in looking at this at the moment is there doesn't seem to be much change over the southern hemisphere, and usually it's much smaller than that. So